Hi and welcome to John's Maths Book. In this video, we're going to be looking at integration by parts. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel if you haven't already done so. Without further ado, let's go over to the whiteboard. Integration by parts is a special method of integration often used when two functions are multiplied together. An example of this would be find the indefinite integral of x cos x dx. Integration by parts says the integral of u dv is equal to u times v minus the integral of v du. So we have x cos x dx. So we need to first find a u and a dv. So let's pick u to be equal to x and dv is equal to cos x dx. So if u is equal to x, as in this case here, du by dx, the derivative of u with respect to x, is 1. And therefore du is equal to dx. So we know that dv by dx is equal to cos x here. So therefore it follows that v is equal to the integral cos x dx. The v in this case is equal to sin x. So now let's put these values into our formula. So we have the integral of x cos x dx is equal to, so it's u, which we know is x, multiplied by v, which is sine of x, minus the integral of v, which is sine x, and du is just dx. So this is equal to x sine x minus, and then the integral of sine x dx is minus cos x. So this is equal to x sine x, minus and a minus make a plus, plus cos x, and then plus c, constant of integration. So let's look at another example now. Let's try and integrate the log of x divided by x squared dx. So using integration by parts, the integral of u dv is equal to uv minus the integral of v du. So let's pick u equals log of x and dv is whatever's left, so dx divided by x squared. So the derivative of u with respect to x, so du by dx is equal to 1 over x, and so du is equal to 1 over x dx. We now need to find v. Now we know that dv dx from here is 1 over x squared, so v is the integral of 1 over x squared dx. So using the power rule, this is equal to the integral of x to the power of minus 2 dx. That is equal to x to the minus 2 plus 1 divided by minus 2 plus 1, which is equal to x to the minus 1 divided by minus 1, which is equal to minus 1 over x. So this gives us u is equal to log of x, du is 1 over x dx, and v is equal to minus 1 over x. So the integral of log of x over x squared dx is equal to, the u is log of x times v, which is minus 1 over x. So that's minus log of x over x. So that's minus the integral of v, which is minus 1 over x, du, which is 1 over x dx. So multiplying those two together gives us minus 1 over x squared dx. So this is equal to minus log x divided by x. And if we take the negative sign outside of the integral sign, it becomes a plus, plus the integral x to the power of minus 2 dx. So that's equal to minus log x over x plus, now we can use the power rule to resolve this integral. So this is plus x to the power of minus 2 plus 1 divided by minus 2 plus 1. So this is equal to minus log x divided by x plus, so the numerator it becomes x to the power of minus 1 and the denominator becomes minus 1. That's minus 1 over x. So if we simplify this, it becomes taking minus 1 over x outside of the bracket, minus 1 over x multiplied into log of x plus 1, and let's not forget the constant of integration, plus c. Now if we look at integrating e to the power of x times x dx, we can again use integration by parts, which is the integral of u dv equals uv minus the integral of v du. So let's pick u. Let's say u is equal to x in this case, and let's say dv is equal to the rest of the expression, which is equal to e to the x dx. So du by dx, we differentiate it, we get 1. So du is equal to dx, and v is the integral of e to the x dx, which is equal to e to the x. So now the integral of e to the x times x dx is equal to u times v. So u is x and v is e to the power of x. So it's x times e to the power of x minus the integral of v du. So v is e to the x and du is dx. So this equals x times e to the x minus the integral of e to the x, which is simply e to the x. So minus e to the x plus the constant of integration, which is equal to e to the x into the bracket of x minus 1 plus c. So let's use integration by parts to integrate e to the power of x times sine x dx. So in this case, let u equal sine x. So du by dx equal to cos x, and du is cos x dx. So dv is equal to e to the x dx. So v is the integral of e to the x dx, which is e to the x. So using integration by parts, the integral of e to the power of x sine x dx is equal to u times v, that's e to the power of x, times sine x, minus the integral of v, which is e to the x, multiplied by du, which is cos x dx. That's minus ex cos x dx. So it seems as though we haven't got too far with this, because we now have another couple of functions multiplied together. So we have e to the power of x multiplied by cos x dx, which we need to integrate. So let's persist with it and use integration by parts to perform this integral. We're going to try and integrate e to the power of x times cos x dx. This time let's pick u equal to cos x. So du by dx equal to minus sine x. So du is equal to minus sine x dx. dv is equal to e to the x dx. So v equals the integral of e to the x dx, which is equal to e to the x. So if we now put this all together, u times v is e to the power of x times cos x minus the integral of v du. So v is e to the x, du is minus sine x dx. That's minus minus, so we'll make this a plus, e to the x sine x dx. So now this integral looks very much like the one we started with. So let's see what we've got now. So the original integral, e to the x sine x dx equal to this part here, e to the x multiplied by sine x, minus the integral of this, which we know is this. So it's minus this, e to the x cos x, plus the integral of e to the x sine x dx. So now if we expand this, we have e to the x sine x minus e to the x cos x minus the integral of e to the x sine x dx. So now if we take this minus integral of e to the x sine x dx across the equal sign, we can combine it with what's on the left hand side. So we then have 2 into the integral of e to the x sine x dx is equal to, and we'll take e to the x and e to the x outside a bracket. So e to the x multiplied into sine x minus cos x. Therefore, our integral of e to the x sine x dx is equal to e to the power of x divided by 2 multiplied into the bracket of sine x minus cos x plus the constant of integration. So when using integration by parts, we need to pick a u value. So as a rule of thumb, try and choose u as follows. So pick inverse trig functions, such as inverse sine. 2. Pick log functions. 3. Pick algebraic functions. 4. Pick trig functions. And 5. Pick exponential functions.